and V of omega Ct is also there. This is not WCT, it is omega Ct, where K is a factor which can be dependent upon the modulating circuit. So if it is going to be adding as well as the subtracting amplitude modulation value with the KVS signal, so you may be written as here final equation how it is representing and in which form it is going to be representing. You can easily observe the case. So 9.4. By simplifying it, you can get the 9.5 equation. This is the equation. Okay. So where K of Vs by V of C, which is nothing but a M of A, which is a modulating factor or modulation index. At what rate the signal is going to be modulated here? Getting my point? If modulating factor is 0, M of A 0 means no modulation. Okay, whatever the signal you are sending, the same signal which is coming out. If MEK equals to 1, means it is indicating that the entire signal is going to be modulated. 100% modulation. So using the trigonometry signal relations, sin A sin B equals to 1 by 2 cos A minus B by A minus B minus 1 by 2 into cos A plus B. By simplifying all these, you may get modulating signal, which is indicating the 9.6 equation. V of C into sin 2 pi fct plus MA Vc by 2 into cos 2 pi Fc minus Fs into T plus MA by same thing. Same is repeated here. Same. But here which is subtracted, here it is added. Okay, MA Vc by 2 cos 2 pi Fc plus Fs into T. Here Fc minus Fs into T. So that is only the difference between these two. So here from this 9.6 equation, the modulated wave which consists of three components. One is the carrier frequency Fc. There is the upper side frequency USF. That is adding the Fc to the signal frequency, carrier frequency. If it is added, upper side. If it is subtracted, lower side frequency. Okay. So several types of frequencies we have been used. So in transmission of voice, so the audio signal is very complex, and the frequency range is 50 to 5 kilohertz. 50 hertz to 5 kilohertz. Okay. As mentioned earlier, you can observe that each signal frequency, which may results the two side frequencies in the modulated wave. Just I want to show you the graphical representation of these. You can easily observe the case here. Okay, so that the in transmission of the complex signal of amplitude modulation contains side bands instead of the side frequencies. You may get here side bands, band, band, okay, instead of the frequencies. This is the case. So upper side band USB and this is the lower side band. What is the range with respect to this is VC is the modulated carrier wave, modulated carrier wave, and above and below. This is the LSB lower side band, this is the upper side band. You can easily observe that. Okay. So the example, with respect to the example is also you can easily discuss the thing. Here, for example, a carrier frequency of 1000 kilohertz. and signal frequency is 50 hertz to 5000 hertz. That is 5K, 50 to 5 kilohertz, and which may leads the band of frequency range is 1000.05 kilohertz to 1000 kilohertz. That may gives you here, you can see here, 1005 kilohertz to 1005. This is upper side. Whereas the lower side band, 999.05 kilohertz to 9950 hertz. Okay, 995 to, this is the LSB. So what is the total bit bandwidth of the transmission of the signal is by subtracting you may get only 10 kilohertz. Okay, this is the case, 1005 kilohertz to here 995 kilohertz. What is the value? Only 10 kilohertz. That is the double the highest signal frequency to be transmitted through this. So what is the experimental determination of the modulation index? That is Vs value is which is subtracted here. There is a print mistake, minus. This is not equal, minus, and this is plus. Okay. So modulation index formula MA is Vs by Vc. Vs is Vmax minus V minimum by 2. And Vc is 2 to get cancelled. Remaining it this equals. Okay, now this is the modulation index. Next is the power relations. Power relation according to the 9.6 equation. Here the voltage components, that is nothing but RMS value, root mean square value of the carrier wave, and the side frequency ranges here. Vc by root 2 into MA Vc by 2 root 2, as well as the MA Vc by 2 root. So these components which are impressed across the resistor here. What is the power value? Power equals to P of T by substituting, you may get here PC plus P of SB. Okay. PC means the power of the carrier. P of SB is nothing but a power of the two side bands. SB means side bands. Okay, now? So that is the case. And Vc square by 2R represent the power in the carrier wave. And Vc square Ma square by 8R, which is the power in each side of frequency. Or Vc square Ma square by 4R is the total power in both upper and as well as the lower side bands. Okay. If modulating factor Ma is 1 means 100% of the modulation is takes place. But the thing is that here Ma is 1 means the power content of the modulated wave. Power, we are speaking about the power here, which is 50% greater than that of the carrier wave. So how the power value is increasing, you can easily observe. Okay. Next is the generation of the amplitude modulation waves. So the amplitude modulation which may produce the combination of carrier and the information signals, which is using the non-linear device. So here diodes, which are the non-linear device. Okay. But they are not used as they do not offer any gain. Gain means output voltage by input voltage is nothing but a gain here. So transistor which may behave as non-linear elements, which offers the gain. Okay, not by the diode. So these are the suitable for this application, generation of the amplitude modulation. So you can see the here a circuit diagram, the carrier frequency signal which is inserted the base of the transistor, and the modulation signal which is coupled either into the emitter circuit or into the collector circuit. Okay, this is the emitter circuit or else collector circuit. Collector circuit LC combination is there. This is the tank circuit. Okay. So the coupling of the low frequency information signal, which can be achieved through an audio frequency transformer, that is capital T. Um, so the amplitudes of the carrier wave as well as the signal wave VC and VS, which are adjusted so as the biasing, sending the signal to the transistor is a nonlinear part of its characteristics. Here the collector circuit which contains a constant, contains a resonant circuit. LC is a resonant circuit, LC combination, which is tuned to the carrier frequency. So what is the resonant curve of the tuned circuit? Which should be broad enough to accept the side frequencies also. So the modulated wave which is taken from the collector circuit. So this is the collector upper one. Center is the base and bottom is the emitter. CER emitter circuit. So how you are going to detect the amplitude modulation signals here? That is also very important. Detection of EM signals. So here a simplest method for the demodulation or detection of AM waves, which involves the rectification of signals and filtering high frequency carrier RF and rejecting the DC components. So here you can easily observe the detector circuit. So the amplitude modulation circuit or the signal, this is the amplitude model. This is the diode we are using. This is the capacitor C1, here is the capacitor C2. At point A, you are sending the signal, modulating signal through the resistor. If it is reaching the point B, the signal is to be modulated. Okay. So amplitude modulated. So this is the RC combination. So the thing is that here the rectifier means a diode which is going to be rectifying the signals AC into a DC. That is a rectifier here. So the thing is that uh, so the combination C1 R1 and C1, which is a low pass filter. C1 R1 C1 is a low pass filter here. Okay. So which removes the higher frequency components, allows only low frequency signals. Okay. Low pass signal means low pass filter, which allows only low signals, low frequencies, and which remove the higher frequency. If it is a high pass filter is there, which allows only high pass, which removes the low pass, lower signals, low frequency signals. So signal suppose over a DC component here at point B, which is eliminated a series capacitor C2. So here only which is going to be eliminate the here higher signals here. Okay. Uh, and which blocks the DC and the clocking allows only AC component here. Blocking DC and allows only AC. So R1 C1 is nothing but square root of omega C into omega S. What is the summary of this chapter means? Amplitude modulation, which is a process of modulating a signal for efficient transmission. MA, modulation index, varies 0 to 1. 0 means nothing, 1 means 100%. So carrier wave can be filtered using the process of demodulation by rectifying the modulated signal. Just now we discussed that. So in communication systems, modulation which can be achieved by a single frequency, which is not used. Several frequencies simultaneously we are using in transmission of voice, audio signal, which is very complex. If contains frequencies, the range is 50 to 5 kilohertz of each signal frequency, which can result in two side frequencies. That what is that? USB and LSB. Avuna? So upper side band and lower side band frequencies. 1000 kilohertz to 1000.5 kilohertz. And here 995 kilohertz to 995.5 kilohertz. That is a lower. Difference is 10 kilohertz only. Okay. That is the case. What is the question is? Draw the circuit diagram of amplitude modulation and explain its working. Next is the frequency modulation and demodulation. Okay. So here let you know the introduction portion of this frequency modulation. FM. So amplitude modulated signals which are influenced by the noise. Okay. NOIS, noise. So the noise appears as additional amplitude modulation of the signal. So the effect of the noise which is minimized in FM, frequency modulation. So in FM, the signal which is placed on the carrier wave and which can be varying its frequency while it's keeping its amplitude constant. So the carrier frequency that is f of c and the amplitude v of c for the modulating signal which has a frequency f of s and the amplitude is v of s. So what is the instantaneous frequency of the modulated wave which can vary sinusoidally with time above and below its mean value fc. Above and below mean value fc. So the number of times per second that the value here uh, the mean value is fc, the number of times per second which goes through the complete cycle frequency. and which may be equals to the signal frequency Fs. So what is the maximum frequency shift delta F, which is known as the frequency deviation? The value is here delta F is given by delta F equals to Kf into Vs. Kf, which is a parameter which may depends upon the nature of the circuit employed, and it can depends on the amplitude of modulating signal. And it does not depends upon the frequency of the modulating signal. See here. This is the carrier wave, this is the modulating signal, center one. Last one is the frequency modulating wave. Here the frequency is which is closer here. Compress. Rare fraction. Here again compressed, here compressed, here compressed. Closer to each other. So here also analysis, mathematical analysis for the frequency modulated wave. Same thing, V of E is the instantaneous values of the voltage of the carrier wave. V of C is the amplitude of the carrier wave. Before that, V of C is the amplitude of the modulated wave. Here is a carrier wave. Amplitude of frequency modulated. So here omega C is the angular frequency, and phi value is a phase angular. Okay. So the modulating signal is also a sine wave, which can be expressed as V of S equals to V of S sine omega S. By simplifying all these things, you may get this equation. And where f of C is nothing but a unmodulated carrier frequency. What is f of M? Modulated carrier frequency. K is constant. Omega S is the circuit employed before. So by doing the calculation part here, by substituting in this above equation, here you may get the omega is omega. This is not W d theta by dt, or else d theta equals to omega into dt. By integrating, you will get the theta value. Again, you can substitute. You can check it once. So you may get theta value is omega c into delta by ts sin omega st. So the analysis of the frequency modulation, unlike the amplitude modulated wave. So this is the f of c, and this is fc plus fs, fc plus 2fs, 3fs. By adding this here, a subtraction is takes place. Left side subtraction, right side is addition is takes place. So what is the bandwidth of this frequency modulated wave? Is a 2 NFS. So signal frequency is Fs here. N is the number of side frequencies, which are pairs of the signal amplitude. And also it may be mentioned that power of the carrier wave is not changed by the modulation. And power in the side bands is derived from the carrier. So a simple frequency modulation generator. This is a CM. Condenser microphone. Inductor is there. Radio frequency oscillator RFO. This is the FMO, frequency modulator output. RF, the signal is there. Okay. So the circuit which can process of generation of the frequency modulation waves, uh, which is a radio frequency oscillator, RF oscillator having a resonant circuit, LC circuit may be resonating. The capacitance are the part of LC, which is not a conventional condenser. It is a capacitor microphone without sound waves. Okay. A microphone presents a constant value of the microphone. The constant value of capacitance, and the circuit oscillates at the particular frequency. Whenever a sound waves which may reaches the microphone, they are going to produce the here vibrations of the diaphragm and microphone, which may causes the capacitance, how it is going to be varied. So the magnitude of the capacitance which can changes, and which is proportional to the amplitude of the sound wave, and what is the rate of the change of the capacitance means, which is equals to the frequency of the sound wave. So as a consequence, the frequency of the capacitor, that is an oscillator, varies according to the above equations, and which is producing the frequency modulation waves. Next is the varactor diode. This is the varactor diode. And this is a sound wave. A mic is there. AF transformer is there. Amplitude frequency transformer. And this is the RF show. On this is okay. CC. This is the varactor diode. This is the tank circuit here. This is RF oscillator, which may fed through like this. And you are taking the FM output on this. Okay. So in this sound waves which are picked up by a microphone and which can be amplified by an audio frequency amplifier. Here the signal, AF signal, amplitude frequency signal compiled to varactor diode. The functioning, the capacitance of the reverse biased varactor diode, which can be varied by modulating a signal. So the resonant frequency of the tank circuit LC, which may be compromising of the varactor diode, functioning the capacity, as well as the inductance, which may be varies here. So the RF oscillator, which is also varies then the frequency modulation of the carrier wave is achieved. So the RF choke prevents the RF oscillation, which is going into the AF transfer. What is a CC value, which is a large capacitor, and which is couples the RF oscillation of the tank circuit of the oscillator, but it can blocks the DC voltage. So these two methods, 1 minute. So the so the methods which are simple and direct methods, there is a reactance modulation, which can be a technique which are available here, like field effective transistor FET, PET, and indirect method like Armstrong frequency modulation techniques. So here they are highly sophisticated and are beyond the scope of this course. Next is the FM detection. So slope detector. That's it. The circuit which is produces an output voltage, whose voltage amplitude which is proportional to the frequency of the input signal, and which can be used to decode or detect the frequency modulation signals. So these are called the frequency discriminators. What do you say? Discriminators. And yeah, this is a simple FM discriminator here. LC tank circuit is there. Radio frequency amplifier is there. So this is the graph which is indicating. Okay. So this is F naught is the resonating frequency. Below F of C is there. Getting my point? Carrier frequency. F of C. Okay. You can easily see this. Like that, you can easily detect this. Modulation index. Delta F by Fs. Change in frequency. This is a signal frequency. What is the bandwidth of frequency modulation wave is? 2n into Fs. Okay. Analyze the expression for frequency modulation. This is also. Next is the elements of super heterodyne receiver. So a radio receiver which is able to select a desired signal using the antenna and a resonating circuit. Okay. So which is amplified the demodulation and uh, and which is information is recovered here, then amplified, and which may fed to towards the speaker, and which can convert the audio signal into sound waves. So this was completely done by a receiver. So what are the functions of a receiver? These are very, very important. So whenever you are broadcasting a signal through the broadcasting stations, which may radiate the high frequency radio waves. So which are called the carrier modulation by the information. So that this may be like a person which is giving a speech, or if a musician is going to be playing a music, or any song which is going to be playing through that, then the modulator adopted may be amplitude modulation or frequency modulation, regardless of the type of the modulation. A radio receiver should perform the following functions. What are the functions means? uh, which may be incorporation, interception of a part of the passing radio waves by the antenna. Next is the selecting the desired signal from the mass of signal interpreted by the antenna. So this can be achieved by using the tank circuit, LC tank circuit. So amplification of received signal before demodulation. Okay. And what is the recovery? Next is the recovery of information from modulated wave. That is nothing but a demodulation. And strengthening the audio signal, which is recovered from the modulated wave by one or two more stages of the audio amplification. Next is the conversion of audio signal into sound waves by loudspeakers. Okay. Yeah. So this is the amplitude modulation receiver. So this is the antenna here. This is a RF amplifier. 1 to n number of RF amplifiers are there. This is the amplitude modulation detector is there. Here also amplitude frequency amplifiers 1 to n numbers. Here in the antenna, between them, detector, RF amplifier, detector, EF amplifier. Okay. Radio frequency, the model detector is going to be detecting, and which we may be converting into audio frequency. So we are sending toward the loudspeakers. So that speaker is going to be gives the output here. Next is the super heterodyne receiver. What do you have in this super heterodyne receiver? You can see here a receiver antenna, and this is a RF mixer is there, RF mixer, and here is a mixer is there, RF signal mixer, IF amplifier, common IF video detector. If video amplifier is there, video, so that which is goes towards the picture tube, CRT usually, which may gives the picture, and here a local oscillator which is connected to the mixer here. Here scanning and synchronizing circuits are there. So which may fed through the audio section, that is sound IF amplifier, FM sound demodulator, audio. Here loudspeaker. Okay. So the functioning. of antenna radio frequency states. How the frequency is converting. IF, intermediate frequency amplifier, detector, automatic gainer, automatic volume control, audio frequency. So what are the characteristics of a receiver? What is sensitivity, selectivity, and fidelity, noise figures, something. So you give the block diagram of superheterodyne receiver and explaining. Yes, yes, a question. This may be short. A principle of superheterodyne reception. Okay. Next, television transmission and reception. TV. So here also you can see the block diagram of the TV here. Microphone, light, television camera. Here audio amplifier, FM transmitters. And here is the transmission antenna. So television camera, video amplifier, modulating amplifier. Everywhere here scanning and synchronizing circuits which are connected and which may be connected to the power amplifier, RF amplifier and crystal oscillator. So this is the basic block diagram of monochrome television transmitter. Okay. So each and every point you need to explain here. What is video camera? What is video amplifier? And amplitude modulated picture transmitter, AMPT. Microphone, audio mic amplifier. Here frequency modulated sound transmitter, antenna, demultiplexer, deplexer. Here is a TV camera and it's working. Okay. How a TV camera is working here. You need to practice all these diagrams. This is the synchronization. Bandwidth, what is the principle of this? TV receiver is also. Don't be confused here. Which diagram is given before. So this ends our syllabus here. Okay. So right, thank you. Thank you, Ananda. I'm signing off.